Let us see what question number 3 says. Suppose sizes of hats are approximately normally distributed with mean 18.5 centimeter and standard deviation 2.5 centimeter. How many hats in a total of 2000 will have sizes between 18 centimeter to 20 centimeter? So here, by using the given information, the random variable is size of the hats follows normal distribution with average 18.5 and standard deviation is 2.5. Suppose we have 2000 hats in our study. So out of 2000, how many hats will be between 28 centimeter, 18 centimeter to 20 centimeter? Let us check. Question number 3, you have to begin with a random variable, and that is like this. X equal number of the size of hats. It is not number of hats. X is size of hats in centimeter. So make a correction in your variable. So X is a measurement. Size of hats in centimeter. Make a correction. It is given that X follows normal with parameter mu, comma, sigma square. In case of normal, mu stand for mean, and due to symmetry, mean can be mode, mean can be median. That means mu can be mean, mode, median, because normal distribution is a symmetric, and we know from your first year the property of symmetric distribution, mean, mode, and median are coincide. Sigma square is a variance, and in question it is given that standard deviation is 2.5. So I write a sigma square 2.5 square. Therefore, X follows normal 18.5, comma 6.25. What we want? We want the probability of hats have sizes between 18 and 20. So firstly, we'll decide the chance that variable X lies between these two numbers. And after getting a chance, we multiply by given sample to get number of hats between this range. Recall your question 1, question 2. When you solving a question of probability for a normal distribution, you transfer X to Z, and the definition of Z is X minus mu upon sigma. So I subtract from each place mu, and I divide each by sigma, so you get this expression. That is named as Z. Z follows standard normal whose values are tabulated. That is the basic reason why we transfer X to Z. By using a calculator, you can simplify this, you can simplify this. So you get probability Z lies between minus 0.2 to 0.6. See the graph. how we represent this in a graph. This is your symmetric curve of standard normal. Minus 0.2 is below 0. It is symmetric at 0.0. 0.6 is above 0. And you want this area. You want this area under the graph. This we find by using statistical table. Remember, statistical table gives two type of calculations directly. What is that? Probability of Z greater than 0.6, this is tabulated. And probability of Z less than negative number, this is tabulated. If it is not, then you have to use complement theorem to transfer in this direction. I want this probability, total probability under the curve is 1. So 1 minus this area which is not colored, that is greater than 0.6, and minus this area that is less than minus 0.2. Total is 1, this gone, so balance is this much. So this is the way to write normal probabilities in terms of tabulated calculation. I have this answer from the book. 1 minus this and this, so 0.30501. What is this stand? This stand for chance that the size of the hat will be between 18 to 20 centimeter. But question is not asking find the probability. Question asking, if I study 1,000 hats, how many hats will have the size between 18 to 20? That is the question. So that will be obtained by making one more line. Number of hats in a total of 2,000 will have sizes between 18 to 20 by making a probability product with 2,000. Simple way. So this product is coming 610.02. So fraction part is less than 0.5, you can forget. If it is more than or equal to 0.5, it will merge here by taking an integer, near integer. So I get answer of 610. So in 2,000 hats which are under study, there will be 610 hats having the size between 18 centimeter to 20 centimeter. Very simple question. Let us see question number 4. Marks obtained by students in a certain examination are normally distributed. Now you might face the problem how the marks follows normal distribution, because the range of normal random variable is minus infinity to plus infinity, and marks is a positive random variable. The reason is, if you study marks, if you make a record of marks, suppose 100 students, you can take experiment this. If you make a frequency distribution of marks for 100 students, and if you draw the histogram, you will find that histogram can be transferred in the symmetric curve. And that's why we consider marks obtained by student as a normal distribution because it satisfies the curve of normal. What the information? If 10% of the students score the marks less than 40, 80% of the students score the marks less than 70, find the mean and variance of the distribution. See now how the questions are different than others. Here we decide number of hats having the size between 18 to 20 by using the parameter. Now here what is given? Parameter is not given. You have a statement in terms of probability. 10% students score the marks less than 40. 80% students score the marks less than 70. And what is asked? To get the information of mean and variance. So in question number 4, probabilities are given and you want to decide mu and sigma square. Question number 3, question number 2, question number 1, parameters are given and you are deciding a probabilities and value of the variable. So question number 4 is totally different. How? Using a probability decide the parameters. Let us check. Question number 4, begin with random variable. X marks obtained by student, given that X follows normal with mu sigma square, mu equal to mean, unknown, sigma square equal to variance, unknown. What is given in the question? Probability X, that means marks, less than 40 equal 10%, 10 upon 100, 0.10. This is first information. And probability of X less than 70, chance marks less than 70 equal 80%, 80 upon 100. So this is the information provided to you in the question. There are two unknowns and there are two information. Simple mathematics. Develop one equation from this knowledge, another equation from this knowledge, and solve them. Consider number 1. Probability of X less than 40 equal to 0.10. Now, just like question 1, 2, 3, we are taking a help of statistical table which is prepared for Z, that is standard normal. And what is the Z formula? X minus mu by sigma. So I subtract both sides by mu and divide both sides by sigma. So you get this statement equal to 0.10. X minus mu by sigma is a Z, less than this, mu unknown, sigma unknown, equal to 0.10. Now locate this in a graph. This is the standard normal. X less than 40, probability is 0.10. B, remember, when there is a less, you speak from your left hand. So I start from left hand and I will stop to locate the value till what I get the probability 0.10. So this is my line up to which probability coming 0.10 from left side because it is below. So this is a location for t minus mu by sigma as per this statement. Now I want to find this number from the statistical table. This is below 0. Why it is below 0? Because due to symmetry, if I speak from left till this 0, this line, probability will be 0.5. My plot is 0.10, so it is below 0.5. That's why this number is minus. So 40 minus mu by sigma equal to minus 1.28. This number from where? It is from statistical book. When our practical will begin offline, at that time I will explain how to look normal table with the help of statistical table. At this stage, just remember this is from the book. Now I solve this mathematics. Sigma taken on the right hand become multiplied, minus mu takes on the right hand become plus. So this is equation 1 for t equal to this. Second statement, probability x less than 70 is 0.80. Again make transformation, x minus mu by sigma, 70 minus mu by sigma is 0.80. Now, just now I told inside probability sign is less, so I speak from left hand. So I start from left hand. I reach till 0. But when I reach to 0, my plot is 0.5. But this is more than 0.5, so I have to cross 0. So this is my location of what? Of this number 70 minus mu by sigma that I wrote here. Now this is above 0 location, so this number is positive. This is below 0, that's why I write a minus. 1.28 from the book and I put minus sign. That's why now here your 70 minus mu by sigma with this much probability will be positive value. And what is that answer? 70 minus mu by sigma equal plus, not minus. This is plus sign. 0.84. Now sigma will be multiplied minus mu will plus mu. Equation number 2. Equation 1, equation 2, solve by simple mathematics. You get this is mu, this is minus mu get cancelled, these both are minus, this will be minus get cancelled, this minus is there, minus minus get cancelled, sigma equal to 30 divided by 2.12. Put sigma in any one equation and you get answer of mu. So this is the way of getting the answer of mean, getting the answer of variance by using probability statements given in the question. Let us see question 5. An unbiased die, you can say dice, is rolled 720 times. Using the normal approximation, find the probability that more than 128 success will turn up. Also find the probability that the number of success will lie between 100 and 140. See now what question says. We are performing experiment rolling a dice, throwing a dice. How many times? 720 times. And you are interested in looking how many sixes you get. So you can transfer outcome of this experiment in two parts, success and failure. If you get a 6 on the upper face, that is a success, otherwise a failure. So I divide my experiment in two categories. One hand success, other hand failure. I roll dice, I look what is on the top. If I get 6 dots, that is my success. If not, the rest will be failure. So how many failures? Totally 5 failures. But it is in one bunch. And how many success? Only one success, that is one bunch. So chance of getting success 1 by 6. And chance of getting failure 5 by 6 in every trial. And each trial is a Bernoulli. You are repeating 720 times. So how many sixes you got? That is a binomial. And it is more than 30, so you can use approximation of normal. Just like your question number 2, what we did. See how to solve it. X is number of sixes turned up in given experiment. Basically, X is a binomial n comma p. N number of trials, here you can make sample size 720. P, probability of getting a success in one trial, 1 by 6. As n greater than 25, I said 30, doesn't matter, 25 also okay. So you repeat experiment more than 25 times, so you are free to apply normal approximation. So what is mu? Mu is NP, which is a mean of binomial. So n is 720, p is 1 by 6, mean coming 120. What is the variance? Sigma square, and variance of binomial NPQ. N is 720, p is 1 by 6, q is 5 by 6. So simplification is 100. So you got mu 120 and sigma square as 100. Do you got it? P is 1 by 6, Q is 5 by 6. It is 720. 6 multiplied 6, 36. 36 with 720. How much? It's 20. 20 multiplied by 5 is 100. Now we want to solve the problem. What is the bit number 1? Probability more than 128 sixes you will get in the experiment. That means probability x greater than 128. Transfer the x to z. X minus mu by sigma. So 128 minus mu by sigma. Sigma is the root of variance. This is z greater than 0.8 directly by using statistical book. Bit number 2, probability number of sixes will lie between 100 and 140. Probability x is between 100 to 140. Transfer x to z, subtract mean, divide sigma. X minus mu by sigma is a z. It is minus 2 plus 2. Draw the graph, symmetric at point 0, symmetric at point 0, and minus 2 will be somewhere here, plus mu will be somewhere here. You want area between this. You want this area. Again, total area under the curve is 1 minus this area is answer of your calculation. Last question, then we'll stop. In a normal distribution, 7% of the observations are less than 35. 89% of the observations less than 63. What are the values of mean and standard deviation of the distribution? Exactly same as question 4. But here variable is marks and this is in general. Observations you label as capital X and then proceed exactly same as 4. X number of observations. X follows normal mu sigma square. Mean is not given, variance is not given, but probability statements are given. Chance that observation less than 35 is 7%. So 7% means what? This is wrong. 7% means it should be 0.07. But everywhere it is taken 0.7, so you make a correction at this place. Instead of 7%, you say here 70%. So you will have less correction. So I can delete this and make a change in the question itself, 70%. If I say 7%, it will be 0.07. That is the way. It is a matter of value, but it is 70%, so this is carried. Same as question number 4, subtract mean, divide by sigma, get a location on the graph. Now this is 0.7. Sign is less, so I speak from left hand. When I reach to 0, then it is 0.5, but it is more than 0.5, so I have to cross 0. So this is your location of 35 minus mu by sigma, which is above 0 because probability is more than 0.5. So table is a positive value. This is from the table. Simplify this. You get equation 1. Statement number 2. Chance x minus mu by sigma, 63 minus mu by sigma 0.89. So this is your probability 0.89. Again it is below, so I have to speak from left hand. If I touch this line, probability will be 0.5, but this probability is 0.89, so I have to cross. So this location is on the right hand of 0, so positive number from the book, that is 0.89. Simplify, this point is 1.22. It is the probability. This is the table value. So solve this, you get equation 2. Solving equation 1 and 2, you get a sigma. Put sigma in any one equation, you get a mu. So this is the way of solving the questions related with normal as applications of normal distribution